Design of automatic loading machine in electroplating industry. Abstract. Earlier, in electroplating industries, all the work was done manually. In 1976, the first semi-automatic plant was set up in India. Thus the electroplating industry has taken a big jump after the introduction of automatic plants. However, there are some tasks which are still being done manually and result in more use of labor leading to inefficiency and tedious work. One of these tasks is loading of barrel. This paper includes the design of automatic loading machine and various components required for the automatic weighing and loading of material into the barrel. It also includes the financial cost analysis of the machine and thus, the break-even time of the machine. It concludes with the benefits of using this automatic loading machine over manual loading. Keywords: electroplating, material, loading, barrel, cost. Introduction. A field. Metals are predominantly being used in almost every aspect of our day-to-day lives. However, one of the major problems in metals is corrosion, i.e. gradual destruction of metal by oxidation, i.e. chemical reaction with oxygen present in the environment. Thus, a special branch called corrosion engineering has been designed to study the prevention of corrosion. Especially, in automobiles, the chances of metal parts getting corroded are high due to the working conditions. The most widely used method for prevention of corrosion in automobiles is plating. Plating is a surface coating chemical process in which a metal is deposited on another metal having a conductive surface. Plating is one of the major processes in corrosion resistance. The advantages of plating include protection from corrosion, appearance, superior hardness and better wear resistance. B. Background. An electroplating process involves a series of chemical reactions with different chemicals to achieve the final result. In industries, these reactions take place in tanks containing the chemicals. The parts that need to be plated need to be kept in one tank for a decided amount of time in which the reaction takes place. After a particular reaction it needs to be transferred from one tank. This process continues until the last tank is reached and all chemical reactions have taken place. The two types of electroplating industries include 1. Manual plant. Manual plant is a plant in which transfer of work between tanks is by hands. The parts are immersed in tanks manually and held for a particular period of time before transferring to next tank. 2. Automatic plant. An automatic plating plant is a line of process tanks with a transfer system which enables the parts to be plated to be immersed in each tank for the appropriate time and in the sequence necessary to produce the required finish. See scope. Manpower is a major factor in any industry. However, excessive use of manpower can lead to reduction in efficiency, increase in total production cost due to salary of manpower, decrease in production and inconsistent quality. In many industries, one more important requirement is skilled labor. Also, the salaries of labor are increasing every year due to inflation. Thus, the main aim in any industry in today's world is to reduce manpower and introduce the use of machines wherever possible to increase the efficiency of working. These issues can be taken care of by conversion of manual plating plant to automatic. However, even in automatic plants, the loading and unloading of parts on barrel takes place manually. At one time, 100 kilograms of material is to be weighed and loaded, which is a very tedious task. This results in increase in labor and thus decreases the efficiency. Thus, one more major problem is how to transform manual loading of barrels to automatic loading in an automatic plating plant. 2. Automatic loading machine. The automatic loading machine is intended to give an output of a predefined quantity of material as per the set weight. Electroplating is a surface treatment phenomenon based on the surface area of the material. However, surface area of a material is very difficult to measure. This surface area can be converted to weight by a suitable conversion factor obtained experimentally. Thus the required output can be achieved by setting a weight limit. Thus, the automatic loading machine transports the component to the height of the barrel and loads the material according to the weight. A construction. The automatic loading machine can be divided into two sections. 1. Loading conveyor section. This section transfers the material from bottom to the height at which it has to be loaded in the barrel. It consists of hooper. It is used to store the material which has to be loaded on the barrel before transportation by the conveyor. It is a storage tank/pit located at the one end of the conveyor. Slat belt. It is the belt of the conveyor section which is used to transfer materials to the other end located at the top. This belt is further divided into compartments to facilitate lifting and transfer of material. Conveyor roller. It is used to run the slat belt. The roller is powered by gearbox which is powered by the motor. Thus the roller runs the slat belt with a speed according to our requirements. Motor. Motor gives required power to the gearbox which is used to run the roller. Gearbox. It is used for reduction of the speed and increase in torque received by the motor according to requirement of the belt. 2. Weighing and transfer trolley section. This section does the weighing of the material and actual loading to the barrel by pneumatic push. It consists of pneumatic cylinder. The cylinder is used to push the trolley forward towards the barrel for loading. When it receives a signal from the system it is actuated. Solenoid valve. When the weight limit is reached, the signals given to stop the belt and start the cylinder are actuated by solenoid valves. Load cell. It is located inside the trolley and is used to weigh the material entering the trolley. Once the weight limit is reached the system sends signals to conveyor to stop and pneumatic cylinder to start. Trolley. The trolley is used to transfer the material from the receiving point to distance where it is loaded onto the barrel. The shape of the trolley facilitates direct transfer of material to the barrel. Compressor. It is used to supply compressed air for actuating the cylinder. The compressor is also used for various other processes like drying in an electroplating industry. C. Working. The working of the automatic loading machine can also be divided as per two sections. 1. Loading conveyor section. The material which is received is transported to the hooper manually. The conveyor belt which runs on the rollers collects the material from the hooper in different compartments. The material collected in each compartment is calculated by experimentation. The rollers are powered by the gearbox, which is eventually powered by the motor. These materials are transferred to a height at which barrel is placed and then transferred into a trolley. 2. Weighing and transfer trolley section. The material placed in the trolley is weighed by using load cell. When the weight reaches the set limit, the system gives a signal to switch off the motor and stop the conveyor. It also actuates the pneumatic cylinder by the solenoid valve to push the trolley forward. The material is carried forward by the trolley thus emptied in the barrel and taken for further processing. 3. Calculations. A selection of motor. 1. Motor RPM. Electroplating is a surface treatment phenomenon. Therefore, the capacity of barrel depends on surface area. Each barrel has a capacity of electroplating 100 sq/foot. Material. However, as mentioned above, it is difficult to measure surface area. Thus, this surface area is converted to weight using a suitable factor which is obtained experimentally. The surface area of one part is measured and various such parts are placed in a vessel whose weight is measured. This is how the weight can be found. According to industry standards, the conversion factor is considered as 1 sq/foot equals 1 kilogram. Thus, capacity of the barrel is 100 kilograms. Loading is done every minute. Therefore, output required is 1 kg/min. To find the effective loading, we need to find the volume of each compartment and thus find the mass in it. Volume of each compartment can be found as 2. Motor torque. For finding the value of torque, we need to know the forces, which in turn are calculated from the mass of all components of the machine and the mass of material. The value of mass for all components is found in the table below by using the formula. Mass equals volume times density, 8. Mass of belt. Mass of roller. Mass of slat chain. Therefore, total mass of all components equals 510.806 kilograms. The total force to be pulled by the conveyor can be calculated by the free body diagrams given below where M equals material, M equals total mass of all components, T equals 50-degree coefficient of friction between belt and material equals 1 equals 0.15, G equals 9.81 m/s2. 3. Motor power. B. Selection of pneumatic cylinder. The selection of dimensions of cylinder can be done on the basis of the formula. Push force equals discharge pressure times area of cylinder. Push equals piece charge times a cylinder, 14. Mass of the material to be pushed. 4. Financial analysis. A. Cost of machine. B. Labor cost. C. Power consumption. 4. Automatic loading. Total annual cost equals annual labor cost plus annual power consumption plus cost of machine equals Rs.12155017. Thus the total annual cost for automatic loading is approximately equal to 50% of manual loading annual cost. Therefore, total annual savings equals Rs.1214983. E. Break-even time of machine. The total cost incurred by manual and automatic loading can be classified into two parts, fixed and variable. Fixed cost includes the cost of the machine which is constant throughout, whereas, variable cost includes the costs incurred daily which are labor and electricity cost. The total cost incurred up to n days can be calculated by the formula. Total cost equals fixed cost plus, variable cost per day times n. Where, fixed cost equals cost of machine and variable cost equals daily labor cost plus daily electricity cost. For manual loading. Therefore it can be said that after 58 days, the automatic loading machine will start giving profits which will thus keep on increasing. This point is also known as break-even time. The break-even time can also be found out graphically. Considering the total cost incurred in manual and automatic loading for a span of 120 days. It can be seen that the break-even time comes out to be approximately 60 days. V. Comparison between manual and automatic loading. 6. Conclusion. Excess labor can lead to decrease in the efficiency. Also the cost labor is increasing every year by approximately 10% due to increase in rate of inflation. Availability of labor is also going to be a major issue in near future. Therefore, we need to rely on some new machines to increase the efficiency and also reduce the cost. The automatic loading machine used in electroplating industries for loading of barrel can be introduced to solve the above problems. It can be seen from this report that the machine starts giving profits within only 58 days of installment. This will reduce the labor cost required resulting in increasing savings every year. Also the efficiency of the work increases. Thus, this machine can be a boost in the electroplating industry.